Hello everyone, welcome to another stream. How are we doing? Right. So today we're going to be working on, as it says in the title, anti-aliasing, which will be the first one, then probably clipping, and then transforms. So last stream we got these gradients done, so we got like a linear gradient, a radial gradient, and then a sort of a distance-based gradient from the edge, which this is obviously my favorite one. Looks super sweet. Big fan of this one. So that's super sweet. So let's get the shaders open. So the biggest problem right now is we've got a bunch of hard edges. So when we've got anything that's not basically square, it gets really zigzaggy. There's no sort of like half transparent pixels to make it look better. Just go and do a nice sort of screen grab. And then we'll compare it. Let's do a full screen one. So we'll go Krita. We'll dump that in Krita, and then we can do a nice little comparison. From the clipboard, please. This one, yeah? Right. So as you can tell, look at all this. Horrible. Like, it definitely makes this shape look a lot worse. So we're gonna get some nice aliasing on here, so it'll just be some like transparent pixels basically. So it's actually really easy with distance fields. Hey there, not so red. Yeah, 6+6. It is a blessing and a curse. How are things going? Yeah, things are going bad. Just been it's been very warm in the UK. It's just, if I can do a spit. Yeah, so they're in 30 degrees centigrade. It's like the summer's just arrived at the end of summer, and it's just been scorching. So I've just not been able to like work out really. But yeah, it's been okay. But yeah, it's just been working. That's about it. How's things been going with you? Yeah, so the worst thing is I have like a lot of gear on. I have a big old PC running with like instances of Visual Studio and all this and web browsers that like proper keep it going. So it gets quite warm in here. So I basically just work shirtless, because it just gets too hot. Yeah. See, the PC I've got right now that we're running on for this stream, right? Because obviously I don't use my work equipment for when my personal stuff. I've got a personal computer. This one is like a ultra small form factor sort of one. Well, small form factor, not ultra small, but yeah, it's just small form factor. And I haven't got like the most beefiest parts. I've still got the mid-range stuff, and it's yeah, it doesn't really kick out too much heat, which is great. It's quite good. Yeah, so to do anti-aliasing, that's what we're going to work on first. It's actually quite simple with distances, right? So we've done it before. So in the past, we had lovely anti-aliased circle and this sort of rounded box, right? Rounded axis line bounding box. So literally you have the distance to the edge, right? And what you need to do is you need to basically, like, after the edge, you need to place sort of like half transparent pixels basically. Well, not really half, but some form of transparent pixels. So we've already got the formula here basically. So just take this and wait, it's all of this. Wait, distance 1. All you need is distance 2. I don't know why I got distance 1 and distance 2. That's probably a bit silly, thinking about it. I'm doing fine, I guess. Got order independent type checking fully working. Now I'm adding unions. Nice. Unions. Are you doing any of that tagged union stuff that people like? I don't know. As a C programmer, I sort of like see this tagged union stuff, and people go, "Oh, but it's so nice because it, you know." But as a C programmer, you just use an enum and a union, and you get tagged unions, and you can fill in all the padding with what you like, and you can share fields between common things, and like I don't understand why people. Like they say because it's safe, but then you end up having to like match or switch all the time on the union, you know? Ugh, horrible. Oh no. I'm good with normal unions, sweet. Yeah, I think it's a bit of a fad. Not gonna lie. Definitely a fad. So we're gonna make it pass instead if it's a pixel outside, right? And then so if it's a pixel outside, so we want to say we kind of want to calculate a t. Yeah, safe. What is that? I don't know. It's it's what all of the kids are doing nowadays. Apparently, safe. Min the distance with what? I'm confused with why. Oh, I see what it's doing. Right. Okay. Right. So basically, we've got ourselves a distance right from the edge, and we're allowing it to be 1 pixel outside. So what we want to do is like, you basically want to say if you're going from one, yeah, so you want to do like one take distance, then minute with, or then minute with 1. So if the value is obviously in the negatives, this will go up to a higher number. So it'd be like 5 or something if it's inside the shape that we've drawn. So then you minute with 1, and then it will say that it's the pixel is always got full on alpha, right? I don't know why I did this lerp. Oh no, of course. Right, okay, we'll talk about that in a sec. And then obviously if the value is above 0, then it starts to go from like 0 to 1, right? You just inverting it the other way around, right? And then so with this, we should then be able to take the current alpha of the color and then lerp that between from 0 to the current alpha. Yes. And you lerp it. Right. So the thing is, we've got a single final color. So this does the blending. So I want to take final color and do the anti-aliasing. So we'll say anti-aliasing try that out. Right, let's blast that. Right. I don't know, it still feels off. I can still see these horrible things. So I think this is wrong. If we can zoom in, you can see these sort of like sharp edges, right? Not very nice. So how do we avoid, so what did we do wrong? Right. See, the interesting thing as well is if we mess with the alpha, we're going to make the front to back. Yeah, we don't want to mess with the, so we're rendering, so we've got a list of commands in an array. And to draw commands, see there's like basically 16, well no, there's 13 on this screen right now. And they're all in order from front to back in the array. And we go over all of them per pixel and just you know, which is obviously very unoptimized right now, but we'll fix that later. So the problem is if we go front to back and we do front to back blending, alpha blending, and we early out if the pixel is fully opaque, but then if we're messing with the alpha of the pixel, it means it won't be fully opaque, and it will cause it to go down to the one behind it, and it will cause it to blend with that one. And that is what you want to do, isn't it? You want it to go to the one behind it in that case. You don't want to just reduce the alpha. Yeah, that's right. Yeah, that's what you want to do. And then it'll blend with the one behind it. That's what you want. So this is calculated wrong somehow. So should we take a picture and just see how it compares? F-width doesn't work in compute shaders because you don't have quads. You don't have the quad 2x2 quads, that process. Which is a bit of a shame. They could have. You can implement it using, like, if you get from the lane next to you, but yeah, the problem is different architectures just, so we're on AMD hardware here, so we have like 8x8, or we have 64 threads that run in all together in lockstep. Or there is a 64 wave 64 mode. There's also a wave 32 mode. So wave 64 means we've got 64 threads running lockstep, and so that obviously makes a nice 8x8 or a 4x4x4. But the problem is wave 32, you can go 8x4 actually, so you should be able to do a couple of 2x2 quads. Yeah. So there is an intrinsic called like wave get lane index or something like that, and you can basically like use that to read from a neighboring lane. Wait. Yeah, and then you can read from the lane yourself and then calculate the derivative. But yeah, I don't know how effective it would be. And you might have to have different shaders depending on the wave size as well. But yeah, shaders. But it's fine. It's fine. You don't need that thing anyway. Yeah, because the problem with using that intrinsic, the F-width one and the others, if you have divergence in your code on a quad, so 2 by 2, if you have any divergence with like if statements where one quad takes the other branch, you just get problems. You know, where if 2 pixels or if a pixel in a quad takes a different branch, that f width gets bugged up. So what have we done to deserve this? So your distance to the edge, it will be basically negative unless it's a bit past the edge, which is what we want, right? So if you say 1 take -2, that would be +3. So then you min it with 1, right? And that would mean you get the full whatever the full alpha is, right? But if you've got 1, right, you're going to be basically 0 alpha. No problems. No problemo. So let's oh my days, I'm messing with the source alpha. Oh, I should be messing with source color, not final color. Oh, what a scrub. Right, that'll fix it. Oh yeah, that looks good. I don't know, I feel like there's an extra layer of crap going on, but we'll see. We'll see. I think that's good. Let's look at the blending. See how it goes. We'll get a screenshot proof, right? So new clipboard. Right, so this is our test subject. So we're getting the anti-aliasing here. This is great. It does make that one look really hard at the top though, but can we just compare it? Okay, so it's hard to compare when this thing dances all over the place. So what we'll do is we'll grab 2 more screenshots and we'll keep the animation still. So we'll find the code and we'll just tell it to just be quiet for a second, you know. Stop animating. So we want to go to that gradient linear. We're going to take, you know, we could just stump out this thing here. There you go. So now it won't animate anymore. And then we'll stump out the anti-aliasing like that. Right, that's good. So we grab a nice little screen grab. We'll close this creator window and open up a new one. And then we'll zoom in here. Wait, why is that? There we go, so we want the ugly. Hey there, Psychode. Good to see you. Welcome back. I had this problem before. I fixed it by making the bounding box a little bigger than the actual shape. Yeah, that's what we did. We made it 1 pixel though, so maybe it's not enough. Pete's Riggs looks like it's being clipped at the top to me, or is it? There's the bounding box. Pete Rig, you have an eye and a brain. I'm not sure how you managed to figure that one out without seeing the code. That's incredible, because we have a bounding box and it's being clipped. It's here. That's incredible. Yeah, so we don't have clipping yet, but we do kind of like, this ends up being a performance optimization, but I think it's going to not be much of one when we do our other optimization. So we have a little bounding box that we use for texturing these shapes. So we just like put a bunch of shapes down and then we'll just take the outer bounding box of it, and then that's where the texture gets applied. So this has like an outer bounding box of here. So that means we have to increase the bounding box by 1. Yeah, help yourself to a little doggy biscuit. Do that, please. Yeah, you deserve that. Yeah, so that's probably the issue, but let's just take the screenshots though, just so we can see it. I want to carry on with the, even though we probably know the answer already. So let's enable the AA. So yeah, we've increased it by 1 here by allowing a distance of 1 after the edge, because negative is inside the shape. Yeah, it is just getting clipped in it. It's just so obvious now when you see it. Would I have figured it out? That's the question. From the experiment. That's a good test, right? Say if we like, right, so we're about, make sure with the right zoom. Okay. So if we put it like, we line it up, would I have figured it out? Why are they both AA'd? Oh, there we go. I don't know, I would have figured it out. I wouldn't have figured it out based on that, maybe. Well, I would say it's not going off the top. Maybe, maybe not. Hard. I don't think I would have got it, honestly. Thank you. Yeah, so, no, it's it. It is in the top, so maybe it's being clipped. I forgot we clip it, to be fair. Background color red. Yeah, the red color was good, but not so red. You made me remove it. Yeah, so we're just gonna then. So the clip shape, I could in the shader be like add 1, but then per pixel, we're taking this. I'm not sure it'd be per pixel because it comes from a buffer, so it'd probably be in like an SGPR, right? A shader register. Sorry, a scalar register. So it probably just gets added in one of those, but you'd be adding it for like in the shader instead of just doing it CPU side. And you'll have to add it multiple times anyway, I think. So what we're gonna do then in the UI, we're gonna be adding 1 here for the anti-aliasing. Right. I don't know, it does look like it's a little bit clipped still. Do again for luck. Yeah, I don't know. Should we do like 2 pixels? Wait, that should be fine. It got smaller? Oh wait, you need to do 2 pixels because you're doing the top and bottom, aren't you? Right. And then you need to... Oh, wait a minute. But then the bottom left needs to be moved back by 1, doesn't it? Something like that. Yeah. So you have to move it. Yeah, what's on the bottom? That's true. Is that right? So you're working based off of a distance. And And the box is only used. See, but this is wrong doing it this way. You know what we're gonna do? Wait. Actually, let's remove this from here. I think we'll do it in the shader. Maybe, because the problem is, yeah, because this code is probably going to get removed anyway. And we also, this affects the texturing. And it's no longer a proper bounding box that's snug. Yeah, but it needs to be that way, doesn't it? Yeah, it needs to be snug around it, I think. So I think if we do a take one there, take one, and then do a take one plus one or something. It's weird, but let's see if that goes. Do I have any plans for font? Any plans for font rendering? So we currently do have a font. It's just a single one. It's this 10 by 10 pixel font, basically. We're just hard-coding to use that right now. But in future, so we just have a like an ASCII, pre-rastered ASCII image. For now, we're just going to use that until we need something else. But yeah, in future, we'll probably just use like STB, TrueType, or FreeType to basically, just do the standard, like you have a single texture font cache, and you sort of take all your text that you're rendering, see if it's in the font cache. If it's not, or the glyph cache. If it's not in the glyph cache, render it into the glyph cache, upload it to the GPU, and then render from the glyph cache. But for now, I just have these pre-rastered glyphs. We're just going to use that for now. Yeah, multi-channel time distance fields is fine. We was playing around with it in the previous thing that I did. When I did the text editor, like a year or so ago. But it's okay. But the problem with this solution is that it uses 3 channels. I guess it's okay. And also, if you want to read if you want to be bamboozled by a paper, you can read this guy's paper on it. So my biggest gripe against this thing, right, is that this library is in C++, and it's not. It is basically like an example of why you shouldn't program in C++. It's really bad code. It's just horrible to understand and read exactly what it's doing. The algorithm that is this multi-channel time distance field is probably relatively simple, and it's just overcomplicated. And then furthermore, you take a look at the paper that this guy has done, and I know he did it for uni and he's probably got to do it this way, but again, it's just so overcomplicated that it's just complete. Well, he did a paper for it. But anyway, it's proper MSDF paper. I think he's removed it. But anyway, it was the most, honestly, it's 60 odd pages of stuff. And I think it's just proving why the 3 channels works. But I tried to read it, and I kind of got some of it, but the rest just went over my head, to be fair. But yeah, the problem with time distance fields as well as text, when the text gets small, it's you need to do multi-sample anyway. You need to basically super sample it and take the average. You need to do 4 samples per pixel, take the average. So it's basically going to be quite slower. So you're better off just using pre-rasterized text. But yeah, if you're doing you're doing like text inside a game, sign distance fields are probably the best. Although there is probably a better way to do text than sign distance fields, like directly. Maybe directly with the actual like the actual path data itself. Maybe. Like I was thinking about it, but I've never bothered trying to do it. Yeah, sciences, they're okay. Yeah, like if you're just doing like screen space text, like rasterized text is the way. Because you need sharp edges, so you need more than one channel, but you do not need two to make more than two to make more edges. Yeah. Yeah, I'm not sure. Right. Do you need more than one channel? More than two to make more edges. Yeah, that's another question I didn't really get answered from the paper. Is like, could you just do it with two channels? Yeah, there needs to be a third channel because the way the algorithm works, like there's like inner edges and outer edges encoded in the red, green, blue or something. It's a bit, yeah. I'm not sure if I quite understood it, to be honest. But yeah. Oh, that did it. Sweet. Right, so we just walk away and pat ourselves on the back. Um, so yeah, we take a screen grab of that. So obviously, you might think, well, that does the outside edges. What about the inside edges? And then you might be thinking, what? Inside edges? Well, let's look how good that looks. Oh, looks great, right? Nice. But there's also inside edges. So these, can you see this one here, how it's a gradient, right? Well, this had done the anti-aliasing for us, didn't it? With the whole distance-based gradient that we've got going on here. But what about something as simple as the border? Dun, dun, dun. They're back, guys. So we've got to fix the borders one, right? Because the border has an edge. And it gets a bit ugly, but we're getting close. What are these for? What the things we're rendering? So it's a little test. It's a little test level. Test scene. So how do we do the inner ones? Well, we've got ourselves the border, where it is. Outline. No? Color bordered. Let's go. Yeah, it's supposed to be UI, but it's crazy LS trip simulator. Exactly. Yeah, so basically, like, because this is meant to be a UI for a game, we want to have a very flexible rendering thing. So we're focusing on the rendering first. So we can have. So imagine if you have like just you have like maybe you have like a button and it has some text on it, and you want to have some animation where it like bites chunks out of the button. Well, you could do it with like pre-rasterized like images that have been made in Photoshop or something. But then what happens if you want to scale it? So this is a way of having a little bit of an extra cost to it performance-wise, but you can do it all at runtime, and you can basically do whatever crazy stuff you got. So we've got like the ability to make any shape out of a circle and a axis line bounding box for now, but in future we'll have more shapes. Quite easy to add. We've got the ability to subtract shapes from each other. So this is a circle being subtracted by two other circles. This is the union of one circle and another circle to the left of it. So it's just it's the intersection of it. So where two circles overlap, basically. This one is just applying like a rounded, just like rounding the edges. This one is doing a smooth union of all the shapes. It's got two circles and a box in the middle. It's just smoothing it out. This is a smooth subtraction. This is a smooth intersection. This is a sort of a border operation on the shapes. And yeah, basically it. So it's a way of having some flexible defined UI that we can just do. And it could be quite, we have something, we can have some like quite good looking UI basically specific for a game. Yeah, so this one is a hard edge. Can you see the hard edge? We're saying if it's less than the border width, pick that or the other one. So that's a hard cut. So we just want to obviously lerp this, right? When in doubt, lerp. It's not too big brain. So how do we go from one color to the other color? So you want to say f32 times 4 color equal, so lerp between the two colors, please. And we're going to lerp from maybe border color to inner color. We'll see if that's correct in a sec. And then we basically want like a t value. Right, so how do we make t? So you copy my theme setup, no worries, it's cool. So if you want another theme suggestion, I actually got this, I got the inspiration from Iceberg. So I use Iceberg for a long time, but then the blue sort of got a bit, you just get used to themes. So I used to use Iceberg, which is another one, just very simple. Just a few colors and off you go. So I used to use this guy. This is not a good example of what it looks like, But yeah, highly recommend that one. But yeah. And then I went and made this theme here, which I can now link to because I remember. I was reminded by Mr. Not So Red that I've got a little thing for that, which is good. So basically what we want to do is make a t value, right? Say t, and I guess we'll end it with like anti-aliasing. And you can then say t is equal to so right. So if we negate the distance, it'll go from like 0 means the edge of the shape. So if we negate the distance, 0 means the edge of the shape, and increasing means more to the middle, right? So and we've got to t's got to be from 0 to 1. So 0 meaning the border color and 1 meaning the inner color. Now we only really want to do it on the edge, right? So when it meets that sort of edge pixel. So so we did like negative distance, the border width. Wait, which one are we going towards? border width take negative distance. So that, say if that's like 16, and then you get, say if you're on 15, you're gonna get positive 1, right? So it kind of needs to go the other way around, actually. So you would say if that's 15, take 16, that'd be negative 1, meaning this guy. Well, kinda. You need to sort of like, right, okay, it will be negative 1. Then as it gets to it, it'll be 0. 0 means sort of like, it still means this thing. Yeah, it still means this one. Then as you go after it, you're going to blend into this thing on the pixel boundary. Now, so this means all you have to do then is clamp it. So clamp F32, 0 to 1. I don't know if you have to clamp it. It might be fine. I don't know. Let's try that out. So, oh, I need to use the S version, so you can have a scalar argument instead of... Right, then you pass in color, and voila, that should be the answer. Right. It's looking okay. It's not quite what we want though, I think. So let's take a look at the... do a nice little screen grab. And we're going to go over to Kurita. I just realized we had this one at the bottom. Oh wait, that's not good, is it? Wait. Ah, pasted it over now. Right. Oh no, that's right, isn't it? It's meant to go to white. Yeah, because they're complementary colors or whatever they are. So maybe that's fine. Should we make one of them red then? See, that's getting aliased there, which is good. Or anti-aliased. Anti-aliased. Oh yeah. Yeah, let's try some other colors quick. So... should we do the, the one on the bottom left? Red and green. Yeah, see, they just get blended. Isn't that nice? Oh yeah. So that's the anti-aliasing all done. Oh yeah. So let's tick that one off the list. So I want to go to here, put that back. Let's go to the to-do list. Right, so we can tick off anti-aliasing. Ta-da! So what we're left is transforms and clipping. And altogether, this black, yellow, red combo is really cool. Sweet. Glad you like it. Yeah, I know people like, you know, into sort of the red into sort of the red color scheme because of, you know, the blue light thing as well. People prefer the red. Yeah. Yeah, it's a nice, it's warm, isn't it, rather than cold. Okay. Clipping. I think I want to do clipping next. So clipping is where it gets a bit fun. So to add even more sort of like a gamey sort of thing to it, let's go into the past when I tried to do some text editor and then I spent ages doing a renderer, as you do. And then what else did I do? Yeah, spent ages doing a renderer. And then I eventually got back to the text edit thing. So yeah, see, I did do sign distance field text. I wasn't lying. So I combined the SDF from like multi-channel sign distance fields or something like that. I used that one. And then I sort of converted it from texture space to screen space, and then combined it with what we've been doing here. And as you can tell, the aliasing is really horrible. But yeah, there's that one. So yeah, here's me trying to sort of like get that distance field to work in screen space. Yeah, so here's the SDF text I've done in the past. But this is why I'm scrolling back on my Twitter, right? Because we had clipping, which was based on SDF shapes, right? Which sounds crazy, because it kind of is. And we're doing like a Mickey Mouse thing, which is for a bit of fun. So we'll try and replicate this, where basically you can define a clipping shape out of sign distance fields. And the thing that can get even more crazy. Oh, thank you, sir, for the bits. Appreciate it. Cheers. So the thing that's crazy about the about this sort of like SDF based clipping as well, other than the fact it can be a really random shape, I was thinking based on the distance you could probably make it a little bit transparent or whatever. You know, you can do some really interesting things that's just not in standard you know, UIs. So we're just gonna spawn. Okay, got the good old hype train. Thank you, Gecko, for the bits again. Appreciate it. Ah, another C programmer, eh? Glorious, my friend, welcome back. How you doing? 4-month streak. Oh yeah. Appreciate that. Appreciate the sub, my friend. How's things been with you? Do you mean like a glow effect? I don't know if I mean like a glow effect, but I guess you sort of like, because we're not really making anything brighter, we're making everything dim around the outsides, if you were to do it based on the distance. But yeah, so it's just an idea that I've stumbled, just thought about. So we've got to add clipping into the UI system, which, shouldn't be too bad. So we've got this sort of like draw API. So you can say like draw shape, ABB, draw shape circle. But we want to be able to push like a clipping shape. So we're pushing like a clipping shape. See, this just pushes it into the draw place, right? But what we kind of want to do is like, we want to have like a clipping thing. So you want to say like UI clip push. Ah. It's going to be the same sort of API, I think. UI clip shape. Yeah. It'll be like a command API. So we just make a bunch of commands. So clip shape, so you can just do that. And then you say clip shape finish. So you can just keep doing as many of those as you want. Then you just say finish. And then what else can you do? See, I guess here we can pass in the sort of like like, how much distance from the edge do you want to alpha? Do you want to smooth? Right. That's a bit of fun. And then you also want to be able to pop. So you can then say push, I guess, and then you pop the shape. Because when you're doing a UI, right, you're basically going down, pushing clip space, and then popping clip space. Right. Alacrity, because all the Rust people, eh? Yeah, I don't know, man. Like, I don't know why you need the GPU to like render a text on a screen. Well, actually, no. Console's probably doing that anyway with OpenGL. Yeah, it's just native into KDE, you know. I don't know. Like, I was on a tiling window manager, and I was doing. I obviously was using ST, right, as all the cool kids do. Oh, it's stuck on Windows 11. Not good. Not good at all. I didn't realize you can get it on Windows. I might have to go and grab that from my work PC. But then again, it's made in Rust, so I don't know. Maybe not. Um, so, what else do we need to add to the internals? So we need another array, right? We need a new GPU buffer. So we'll make another array on the CPU, then we'll copy it over. And this is going to be our clip commands. See where we're going here? Gonna get beautiful. We'll have a bunch of clipping. Or you have a clip stack or whatever. Clip stack words or whatever, and you just process a bunch of little shapes and keep it going until you hit a finish mark, I think. So I think we want to say draw commands. So we might have another one. And the reason why is because you can have multiple draw commands share the same clip shape. So you don't want to have it encoded in every single draw command, because it could just be one shared clip. So a draw command is just going to be U32, which means we probably do the same for like a clip command. Something like that. Something like that ought to be good enough. So clip command and then you clip words. Something like that. It's two arrays, right? An array of little commands which has a range of words. And the words are just a bunch of, it depends on the type, right, that we process off. And then we have an array of words which these point into. And then you want to have like draw command word start index. So the clip range, you'll probably just pass in a clip index. Clip index. Clip command index. But do you need a clip command? All you need to do is point into the. This is too many arrays, I think. All you need is one array. Your clip words, something like that. Yeah, clip words. So you clip word start index, and you'll read the words until you hit the final word, or something like that. There's an alert. No, I just got you guys up on the chat here. Does the SDF all fall off at the same rate, or do you have to normalize with pixel derivatives? Right, are you talking about with the anti-aliasing we've just done? But yeah, the SDFs are all about the same. Yeah, it's a distance from the edge, right? It's a signed distance, so it gives you a distance, and that distance is always. Yeah, it should be fine. Let's see why not. Um. Right, so just got to allocate this lovely array. So wherever that is, when you initialize, obviously. Clip words, and we'll have clip words capacity. Sort that one out there. Very nice. There's also another one called clip words. So what happens if you don't have any clipping? That's the problem. So we need to start it off as a finish or something. Yeah, so we can either encode like a null byte in there. See, I haven't got my any enums yet, so we're going to get those sorted out. So the one thing about it working is like the draw one, where you have like an enum. You parse the first 4 bytes, you pick up the enum, and you go, okay, I got a circle here, and then you read the next words off to get the center position and the radius, that sort of thing. So we want to do this again. Complete crazy, but it's fun. So I think we want to do this. Have a clip type. And I think we might need a clip type finish or none. So it means you could theoretically push on a clip space of nothing. Yes. So you can push on an empty clip. Have you? Maybe. Think about that one. We'll say finish. So yeah, I guess the start index is just going to be 0, so that's fine in the initialize. Very good. Right, so what else do we need to sort out in this array? I think we just need to start actually putting stuff in there now. So if we go over to that clip shape thing, the way they'll look... Wait, we need some more internal functions. We need a way to push on clip words. Clip words. So we'll take that here. We'll take all these and make clip word versions of them. Let's just add words to the word array. Very simple. Draw words, clip words. And then we'll just change them quickly. Yeah, I just think it looks nicer. Like, this just, you know, people end up doing that to make it look nicer. But I don't know. Yeah, I just like this single line. Alright, so when you do clip, does it have to be called between draw? No. So you're just appending. Appending. So the draw words, no. Sweet. So what are things that we can fill in? Getting quite dark in it, switch on that light. So when we push on our lovely shape, we're going to do it like we've done for the draw one, right? Shape, circle. We just do something like this. So the way the API is going to work is you just push on the commands and then you say shape, circle, shape, box, or whatever, clip, and then you say like clip push, and that will finish it, I think. So we just want to say push. So where it says draw, you're going to say clip, 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 clip. Get rid of this bounding box because we shouldn't need it anymore. Don't need the end either, we're just going to push on some words. So clip, type, shape, circle. Sweet, shape ABB. Just going to grab that one now. And then we push on the words for the center position and the radius, obviously, and then we do it here as well for this one. Clip, clip, clip. And there you go. So when you do a push, all we're doing is we're pushing on another one, and that's just going to say finish. So when we issue our draw, every draw is going to have an index into this word array, and it will just look at the first thing and see what type it is. If it's a shape, it will test against the shape. And but if it comes across a finish, then it would just like we're finished in the clipping entirely. So I might have to do something in the shader where if it comes across a finish, or if it doesn't come across any shapes, then it should just accept any pixel basically, or something like that. And then what pop is going to do is pop will have to remember where the last word was. So we have to have a stack of clip. Yeah. You see, I've got all these like dynamic arrays. I went and made like a dynamic array thing, but I've just gone in a hard code. I just done it like this. You know. But anyway, that's fine. So you got the clip words. So we need to have a stack of clips. Like a clip stack. So, you know, I do have this sort of like core stack, U32 clip stack. So we should really be using this. Now I considered doing the keystrokes. Yeah, I did do it for a bit. But I think like most people didn't really get much. You know, I ran a few polls, and I think people don't really like it too much, to be honest. Yeah, that's about it. I think it wasn't end up being as useful as you think it might be. But yeah, and also I've got entirely remapped Vim key bindings as well. But yeah, my Vim skills are okay. Like I've went and learned enough. You know, I could really learn more. But yeah. Should I switch over to the stack thing that we've got? Right, should I switch over to this? It would be a little bit clearer to understand, right? So the idea is when you do a finish, you want to push on the clip stack. So you want to say like core stack push. And then you can say like take the address of GUI.clipStack, and then you push on whatever the current word is. Wait, do you do that here? Yeah, you push on the current word, and you can always look at the one before it or something like that and pop that. And restore it back, I don't know. Yeah. So you're gonna say like G equal GUI dot clip words, and then you want to do like a core stack count. Yeah, I've got to switch over to this thing. I can't believe I made this and didn't use it. Right, there you go. So we want to like find where we use those arrays now and sort this out. Oh, we've got smooth distance. We didn't think about that, did we? Smooth distance for me, please. Forgot about that one. And then a pop. All a pop is going to do is pop off the end, and then it will read the top one. So get last. It will read that, and we set the count. So you do like a call it like count, and then you want to say like core stack resize, and you're going to resize GUI.clipWords. Wait, is that right? No, you don't want to resize it, do you? Because then you're going to overwrite the clip. Wait, so you don't need a clip stack then? So if we have this sort of like user interface and we're going down a tree of nodes and come back up a tree of nodes, you do have this rectangle that you sort of like, so that you're maintaining. Yeah, so maybe you just maintain the rectangle in a stack. So you don't really need a clip stack then. Okay, my mistake. Get rid of that. No biggie. Right, so we just do a... So there is no pop. That's mainly in the UI system itself, but not in this little renderer thing we're doing, basically. All good, nothing bad about that. So now we've got rid of clip stack. That clipping thing is basically done. We've just got to rewire the, we've got to set it when we issue a draw. And also we've got to change these arrays here. So well, we've changed these arrays now. So this does a push, but we can just use the push thing here, core stack push, address of GUI.draw commands, and we're going to push command on there. Get rid of all that, get rid of the comment. Much better. Now these words, we're pushing on 4 words, and then we're doing this. Right, so you want to get a little pointer. So here's your AABB words equals core stack push many. We're pushing onto that GUI.draw words. We're pushing 4 words on. So we can push on this bounding box, and then this all here would be, that's one of that. Nice. So this is all about the clip words. So we're pushing on to the clip words by count. And then we're going to loop over count and set them all up. Like that. Crap. DST words. Very nice. Then pushing singular is something like this. Equal word. Then these just use the other ones. Nice. Implicit start. So this is when we start a new draw. So when we push a shape on, we check to see if we use one of those UI draw shape, it will use this implicit start to see, do we even need to start, do we need to start a new draw, basically. So core stack count on there. For AABB, right, so it shouldn't have been a push. The thing earlier shouldn't have been a push, damn it. Right, let me rewind that for a sec. Right, let's grab all this. We'll be back. Let's restore this guy. So the reason why we restored those is because this one actually needs to just put them in the array, because it puts them at the start of the command. Draw command word start index, puts them right at the start, so we can check the bounding box there. Now, when we set this thing, when we start in the draw command, we need to up it by 4, which is just the same as reserving for. So core stack push many. So we sort of like, we set these later. And draw finish. Something like that, yeah. And then, right, this ups it for the number of words in a draw command itself, not the overall words in every command. Because just a linear array filled with little mini arrays inside, basically. Sets up a new bounding box. Push many draws. Right, so this is like the other one, where you want to destination words equals core stack push many GUI dot draw words. And we push in this many words on, and we're simply just storing in the new words that we've allocated inside the array. Cool, getting close. Then this adds the number of words to the actual draw command itself that we're currently working on. This one wants to push a single word. So it's like that. Push singular. Cool, so now we're updated everything there. And this wants to clear the arrays. We've got a nice clear function for that in these lovely stacks. Now, the thing is, we also want to clear out the clip words as well. And the draw words. There we go. Very nice. And we need a new array here for the clip words as well, so we can put that into a new GPU buffer, which we'll sort out very soon. Core stack count, take the address, put that down like that. And there you go. Right, so I got to add the clip words as well. Nice. And these have to be made using the core stack initialize. Take the address of the stack, pass in the allocator, something like that. Oh, nearly there. Sweet. Are we compiling again? We're compiling. So, the last thing we got to do is we've got this, right in this UI thing, is we need to make sure with our draw command that we finish. When we say draw finish, what we need to do is we need to add a new word in here, which is going to say this is where the clip shape is, right, or where the clip words are, so for you to sort of analyze. So we've reserved for the AABB. So that one you would need when you do the when we do the tiling. We'll need that one. So we'll keep that first, I reckon. So what I want to do is actually reserve 5. And the clip words start index. This is lovely. I just realized we won't need this clip command anymore. That was useless. So here at words 5, we're going to patch in the clip. But you don't need to patch it in, do you? Because you kind of have it anyway. You patch the ABB because you only know that when you've done all the shapes. But when you start it, you have it anyway. So that will mean you can just do a single push. And you say based. So you need to know where the previous one started. Something like that. Where the previous. So we don't have that right now. We need to know where the previous. Like, where's the clip word start index? Like, where is that one? So we add 1 word equal GUI clip word start index. So we just got to somehow set this thing up now. How do we set this? So when we call this sort of like clip shape, like, so yeah, it's only really when you finish right, so it starts off with nothing in there. We need to kind of like, when you start a frame, we kind of want to say, right, push on an empty clip shape. So it doesn't clip with anything. And then, so the previous start index. Did we delete something? We shouldn't have deleted. So that should be equal to 0. Yeah, let me check my Git. Draw command word. Yeah, that's fine. Okay, we didn't do anything there. Yep, that should be fine. So if we set this thing back to 0 again, and then we push an empty clip, that's fine. At the start of a frame. So now the problem becomes, you want to do a new so when you say clip shape, when you say clip shape, there's a chance that you're starting a new one unless the clip shape has already been. Yes, you need 2 variables. We need a clip word Um, so you got like a start index. That's for the current clip shape. But you also want to kind of say like it is starting. You kind of want a Boolean really. But you could equally just use a negative number to represent it possibly. So 0 means, so it's a negative number, means clip shape means clip since UI clip shape. Right, so you need to, it's like a little check. So we start off at 0, that's fine, that's valid. So when you call, I think we want one of those sort of like implicit starts on the clip shape. Clip implicit start. So the clip implicit start, we're just going to call it every time we need to. We'll say if. So I think we'll do an assertion. Core debug assert. We'll make sure that GUI dot clip word start index of that clip word start index. We'll make sure that is. Wait, do we? No, I think we don't care. We say if it is positive, then what we would want to do is make it negative where it currently is. So you'll say, oh, well, it's currently at core stack count GUI clip words, something like this. So just point it to the end of the array where the words are going to go on for the clip shapes you're about to place on. But then make it negative, right? So you cast that to an S32 and negate it. Now, what else? Yeah, I think that's basically all you want to do. So when you say clip shape, you just call this implicit start, get a nice bit of code sharing. And then what else do you want to do? Well, when you do a finish, you then want to flip that thing the other way. So the first thing you want to do is core assert that GUI dot clip word start index that has to be negative, and if it isn't, wait, is that right? Because I can't say -0 at the start, can I? No such thing as -0. So that would mean, well, you know what, you can just finish. So we just say if it is negative, flip it. If not, just leave it where it was. Is that fair? No, if it's negative, flip it. But if it's not negative, then set it to whatever the current count is. Set it to what the current count is instead. And then push the words on, and then it will always just point to finish right away. That's a good one. So that means what we can do. Oh no, it'll be fine. Twitch is down. Is it? So I guess it could be down for some people. I think Ransel was saying it's down in the Discord. Ransel was saying it was down in the Discord. We got. Seems to be running for me. Yeah. There might be in a few countries. Um. So we just got to put an assertion in, right? I know I just said that the past 2 times and got rid of the assertion, but there's one more place where an assertion is needed. When you do a draw, you don't have a half-finished clip, right? Then that's weird, isn't it? So whenever you do anything drawy, and also when you do anything clippy, I think. When you do anything clippy, you don't want to have a half-finished, or do you? So if you're doing these draws, you kind of want to set up the clip thing first. Yeah, because it gets a bit weird, doesn't it? So go to this guy. What you're going to say is give me one of these stat debug asserts. Then, so clip. So this one has to be positive. And if it isn't, then draw can only be called you want to say like cannot be called when UI clip star has been used and not finished with push. We could call it clip finish, really. Push is a little bit of a silly, but anyway, we'll change it. So you want it there, but you also kind of want it at the color assert as well. Because when you do any coloring, and probably when you do any finishing as well. Draw finish, right? Something like that. And then when you do your, so you save your mid draw, you also don't want to come along and be able to change the clip. So your mid draw, when something like this is called, right? So something like in that clip implicit start or something we called it, we kind of want to put the assertion here and say that when something has been drawn, so you want to say it's not or is equal to this. Your clip star can only be called when nothing is in the middle, or cannot be called after. How did I say it before? Cannot be called when clip has been used. Yeah, let's grab this one. This was good language. Me from 2 seconds ago. Cannot be called when UI draw has been used and not finished with UI draw finish. Bam. So clip finish when we roll in with that one. You know. UI clip finish. Right, so I think that's all the bells and whistles we want. We just got to obviously do some shader code and write some test code. Wait, where's the clip? Push. Oh, here it is in the public interface. Right, so here's our, that's what we spent our time wiring up right there. Ah, is Twitch slowly going down then for people? That's weird. Hmm. Uh, right, so we're going to put one shape on. It's going to be amazing. Going to be amazing. Center of the screen. We're going to chuck on a super nice circle. And we're just going to have it sort of like make it take up the radius of the screen or something. And then we'll add that sort of like fading thing on it as well, because I think that would be a bit of fun. So we'll start off with just one shape, obviously, and then we'll do multiple shapes. And then we'll do different clipping as well. Make it change. Um, um, See, one thing we could do is we could ask for the current clip. What is the current clip word? And then we could, or what is the current clip shape position in that word buffer? Remember that, and then restore it back later, because that might be great for the UI actually. But yeah, we'll think about that one. Yeah, maybe there's a way to explicitly set that. Yeah, that's probably quite good actually. Where is it? Clip. So when we say implicit start on the word, on the draw, sorry, we set it to wherever this is. This gets, okay. So we might want to say like, what is the, in the UI then, we might want to ask, hey, what is the current clip? Maybe just say like, get current, set current. Wait, it's the other way around, isn't it? I think that would be good. And I just made getters and setters for a simple field. Look at me go. It's so bad. Sounds similar in a way to the pen concept for drawing. Ah. Pen concept for drawing. I'm not sure if I get you. You mean like our API in general? Or something to do with the clipping? So we just get it and then we set it. This is the pinnacle of me what I hate about Java. With those getters and setters everywhere, but I've just gone and done it. Anyway, APIs. That way it's just a function and you can tell. Right, but anyway. Maybe I can think about that better, but yeah. Don't know why I just did that. It's weird, I can't watch the stream from the mobile app, but the browser works fine. Ah. Right, I see. So my entire Gen Z audience can't watch the stream. But the other thing is I'm viewing the stream on my phone right now. I'm viewing the chat though. My phone right now. In the chat though. Right, it does work. Apparently. So we do a smooth distance of 0 for now, but we'll be at making that good. You know what? Actually, let's put 50 pixels in there. But it obviously will do nothing at the beginning. So what is center of the screen? Well, it's temp width divided by 2, temp height divided by 2. What is the radius? We want to fill the whole screen up, right? So you basically take, well, the shortest edge, which is the height, divided by 2. Voila. So that right there is going to be our clipping shape we're going to start off with. So we're just going to clip everything. Everything's going to be clipped by this that we've got, you know, our beautiful thing we've got. Oh boy. So we're obviously messing up the words. So some of it doesn't get interpreted correctly. So it starts interpreting sometime, yeah. So we've added a new word in to our stream of words. It's like I'm speaking some cryptic language here. But yeah, we are. So we in the draw finish, we added like where is it? Not the draw finish. And the draw start. Yeah. So we have our draw command. It's got an array of arguments basically. We call them words, right? They're 32-bit integers, and there's 4 of them which make up the bounding box. Then after it, we've sneaked in a new one, which is clip word start index. So for where the clipping information is. So because it's done that, it's offset all the other information. So it's just started interpreting it as a bunch of garbage in some cases, but sometimes it still draws. Really weird. I'm surprised it still draws in some ways. Yeah, so we obviously just got to interpret that data in the correct way and then it'll be fine. Sweet. I'm just going to quickly go and fill up my big glass of water and then we'll come back and get this nice clipping shape sorted out. But yeah, I'll be back in literally a couple of minutes. So enjoy the little tunes. All right, welcome back. Nvidia? No, I got an AMD card. AMD for the win. No, I just like AMD better because they contribute more to the open source sort of side of things, you know, open source kernel drivers, open source stuff for developers. You know, they do some pretty good stuff. I've had like a bad experience with AMD though in the forum. Like someone basically just like disregarded my bug and didn't bother checking into it properly that I had in their kernel in their driver. But yeah, so I just had to go around the problem. But other than that, they're pretty cool. Much better than in video, in my opinion. Um, so yeah, we just got to process the clip stuff in the shader, right? So basically, we go over all the commands. We've got our commands. Our command is just a 32-bit integer. It's got 24 bits for the word start and 8 bits for the number of words. So we fish those boys out, get ourselves a nice range of words. And these are just arguments, remember? So we pick off 2 words and turn those into a vector 2, which is the bottom left coordinate of the bounding box of the shape. Pick off the next 2 words, and that's the dimensions of the bounding box of the shape we're drawing, of the shapes we're drawing. Now I've got to pick off another word, and this time it is the clip words start index. Now, what's great about this lovely is there's always one of these guys. Oh, I didn't make my array, did I? So we need to add a new GPU buffer. Crap. 1, 2, 3, wait, 4, 8, 12, 16, 20, 24. Yeah, wait, we've got plenty. This is good. We've got a limit of 64. I was thinking I wasn't going to go over it soon, but we're fine. So I need to set that up. So we need to make sure that we have a new buffer. Clip words, buffer, clip. And then we need to upload to that buffer every frame. So we do that here. We want to get our clip words using the API that we exposed, right? And then we want to use the GPU upload buffer, and we upload to the buffer like so. Copy paste for the win. So we need to go ahead and add that into the global graphics thing here like so. So there's a new resource ID. Now we need to not forget this thing, if not we're going to drive a crash, because it's basically an index. We need to set the clip words like so. Now we've got the buffer set up, all good. So we've got a new buffer on the GPU with all our clip words in it. So now we can actually fish those out. The clip word buffer is passed into the shader, and now we can start using it. So we need to get a word, UI word. We're getting a U32. Oh wait, from the draw words. Don't mind me. Yes. So now this is where the fun begins. Anakin Skywalker. So we need to do a while loop. And we're just going to loop forever, I guess. And the idea is we want to loop until we reach a word that tells us to finish. So we'll go through the clip words. And we're going to use clip word index. And we'll get ourselves a clip type. So this will be UI clip type. And then we switch on clip type. And then clip type is just going to be that super lovely enum that I quickly threw in here. So we've got finish, circle, and AABB. So we're going to be doing a distance field again, right? So we can join it all together. So finish is just going to break, right? It's the wait a minute. Finish is going to break out of everything. We don't have go-tos. What have we done? So we should probably do a break here. but then say if clip type equal finish, then break. Anyway, if not, go down here. Now, I guess we can remove that from there. So, what do we do here? So we want to basically get a we basically want to get a distance, right? And we're building up. We just want a union. See, I think we want it automatically union. Maybe, I don't know, because the thing is about the current draw type is it allows you to, like, when you draw these shapes, you can say, oh, I've got a circle and a bounding box, and we're gonna like subtract one from the other and make this weird thing. Now we could do that with clipping. We can do that with clipping also when we build these clip shapes. But then I feel like it could, like, you're just asking for, like, well, it's not bad performance unless you actually do it, maybe. It is flexible. So if you did, if we did this union thing, you'd need a distance. Well, you can work on the current distance stack, right? So we have like a distance stack where it stores temporary operands and it allows you to join and subtract things. So I imagine like you can make like a moon cutout for some reason if you wanted to, right? So I think let's like ignore that for now. Let's do the most basic thing. We'll do this sort of, we'll do it with all of the lovely bells and whistles we've got with these unions and things. And what we might do honestly is just reuse this. Reuse this one, this enum for the clip. Just get a distance, and the color stuff will just be ignored or something. Something like that. But for now, let's just show the power of the yeah, because I might want to move, maybe we move this into another function or something. And you end up having to call it twice, maybe. I don't know. Yeah, maybe this goes into a function somewhere and it gets you a distance. Think about that. But let's just try the thing out. So we get a circle, right? We just want to do an SDF for a circle. We're going to grab the code. Here's one I made earlier. So let's just assume there's always a clip shape, just for the sake of, well, yeah. So you want to say like clipped equals false. True maybe. Awesome, Ransel. How you doing? Welcome back. How's things been? So you extract your words out from the clip words, I guess. Clip, clip, clip. And then you want to get the difference and then generate your distance. So you'll get a distance to the edge. And then we'll say it's clipped. Or just in one shape for now, just to show it off. Clipped if distance. So negative means you're on the inside of the shape. So if it's positive, you're clipped. And voila. So let's try this out. Hopefully it doesn't crash the GPU. You've been warned. Oh no. It happened. Oh no. That destroyed the stream. Struggling to keep up. Right. Are we still going?